welcome to this deep dive. We've got a, well, truly fascinating stack of sources you've shared with us, and honestly, they take us on quite the intellectual journey.
That's right. At the core, we're looking at a specific geophysical technology, sort of a novel method for exploring deep underground.
Yeah, and it involves a particular sensing method and this associated algorithm called RALF-1.
But what makes this stack so compelling, I think, are the potentially surprising places these sources claim the technology's capabilities might extend.
Right. We start grounded in geology, looking for resources, but then things quickly move into claims about predicting complex events across fields you'd never typically associate with geophysical surveys.
Things like finance, weather patterns.
Even geopolitical situations. It's quite a leap.
And the source material itself reflects this breadth. We have technical reports, project proposals, and analysis.
Here's some partnerships. It's a real mix.
So our mission in this deep dive is really to unpack all of this.
Yeah, we'll try to extract the most important nuggets of knowledge and insight, figure out what the sources present as, well, most significant, and help you understand the picture they paint.
Okay, let's dive in.
Let's start with the foundation presented in the sources, the geophysical method itself.
Okay, so they introduced the idea of finding resources like water and hydrocarbons far beneath the surface. We're talking depths where traditional electromagnetic methods often struggle.
And the sources propose a specific technology for this. It was initially framed, interestingly, for challenging environments like Mars or other cosmic bodies.
But with clear potential for Earth applications, yeah. It's given a few names, including the laser beam method for anisotropic frequency sounding of induced polarization, or LBM AFSIP-B DC.
Sometimes shortened to AFS-IP-LB method. Quite a mouthful.
It is. And what's particularly interesting here, according to the sources, is how it aims to achieve deep penetration.
Right, unlike higher frequency EM methods that might only reach shallow depths.
Exactly. This method claims depths comparable to seismic surveys. The sources mention reaching up to 6 kilometers for water and hydrocarbons, possibly even up to 10 kilometers.
10 kilometers. That's a staggering depth. How do the sources actually say it achieves that kind of reach?
Well, the mechanism described is quite different. It apparently relies on using orbiting satellites, directing laser beams at the surface.
Lasers, okay.
And then using large magnetic loops on the ground for transmitting and receiving very low-frequency signals.
Low frequency. That's the key, isn't it?
Seems to be. This use of low-frequency signals is crucial because, as discussed in geophysical literature like that Vanyan source you provided, lower frequencies penetrate much deeper into the Earth than high ones. It's related to something called the skin effect.
The skin effect, right. So the lower the frequency, the deeper the EM waves can travel before sort of dissipating. Okay, that explains the potential for depth, at least in theory.
And the claims about precision are also quite specific.
Yeah, what do they say?
Well, the sources talk about identifying salt water or hydrocarbons from 0 to 10 kilometers with an accuracy down to the first meters of thickness.
Meters at 10 kilometers.
And the associated algorithm, this RALF-1, specifically claims 2-meter precision on hydrocarbon saturation. Now, that level of detail at such depths, if it's true, would be, well, remarkable.
It really would. The sources also try to ground this novel method a bit by drawing analogies to existing electrical exploration methods.
Like sounding with vertical currents proposed by Vladimir Modulatov.
And techniques using Earth sources, which are discussed in that technical geophysics source. It feels like they're positioning this within a recognized family of geophysical approaches, albeit pushing the boundaries quite significantly.
Okay, so moving from the sensing method itself to how the data is actually processed brings us to RALF-1.
Right, RALF-1. That stands for Reflection on Actions of Lorentz Forces.
And it's presented as the core inversion algorithm used to interpret the data gathered by that AFS-IPLB method we just talked about.
And the documents give some background on its origin. It's described as a patented algorithm, patent 261617114RF.
Developed by Vadim Chernov specifically for solving inverse problems in mathematical physics, separating influences, and forecasting.
Forecasting, too. Interesting.
Yeah, and the analysis of the algorithm's code you included gives a bit of a window into its claimed workings.
What does that show?
It's primarily a Python script, apparently for geophysical data analysis. It uses custom random number generators, various filtering techniques, including Fourier transforms, and iterative data adjustments. It's noted as being computationally intensive, using parallel processing.
Okay, but here's where the sources take a turn towards the Well, the conceptual, almost philosophical.
We mean the observer idea.
Exactly. They present RALF-1 not just as software, but as representing an observer. They even draw a parallel to Thomas Young's famous double-slit experiment.
Suggesting that just as the act of observation can influence the outcome in quantum physics, RALF-1 somehow acts as an observer in analyzing data, influencing the insights derived.
Yeah, that's the analogy they make. It's quite a leap.
It's a fascinating framing, certainly. And the principle guiding this observer algorithm, according to the sources, is Occam's razor, the idea of favoring the simplest explanation.
How does that apply?
They claim it's used within the algorithm to discard redundant parameters and find the most straightforward solution fitting the data.
The observer concept is still pretty abstract for a data processing algorithm. Do the sources really explain how an algorithm functions as an observer in this sense, beyond just, the analogy?
Not really in great technical detail. It's presented more as a high-level principle or a characteristic of the algorithm's approach to finding solutions in complex systems.
And about Occam's razor, how does that practically work in the code?
Again, the precise implementation isn't fully detailed in the materials we have. The implication is just that it helps the algorithm cut through noisy or conflicting data to identify the most probable signal or pattern, sort of like finding the simplest path through the noise.
Okay, so we have a proposed deep sensing method and an algorithm that processes the data, framed in this somewhat abstract observer way. But this stack of documents makes claims for RALF-1 that go significantly beyond just geophysics.
Oh, absolutely. This is arguably the most surprising part.
Right. The sources attribute predictive capabilities to RALF-1 across an astonishingly diverse range of applications, fields seemingly unconnected to the Earth's subsurface.
Let's list some of these claimed applications because they are quite something.
Go ahead.
Okay, so the sources claim it can forecast trends in financial markets. They show a chart suggesting it predicted extremal growth in cryptocurrency.
The currency.
And more specifically, they reference a Brent and WTI oil price forecast from April 2019 that allegedly anticipated a price peak following a Saudi drone attack framed as a black swan event.
Predicting a specific black swan event using what started as a geophysical algorithm. That's an extraordinary claim.
It really is.
Do the sources offer any explanation for how an algorithm designed for analyzing geological-induced polarization data could possibly predict something like oil prices or crypto trends? Is there any theoretical link proposed?
Honestly, no. The sources don't provide a detailed technical explanation for this cross-disciplinary predictive power. They mostly present the results, like the alleged oil price forecast accuracy, as evidence of the algorithm's capability. They don't really connect the dots on the mechanism.
Okay. What else? They also claim applications in meteorology.
Yes, one source mentions a prediction for atmospheric stream deformation over the San Andreas fault zone. It claims it differed from NOAA's prediction, but was confirmed by real weather on a specific date in November 2018.
Again, the mechanism for jumping from subsurface properties to upper atmosphere weather isn't really explained.
Not in the documents we reviewed, no.
And medicine. Predicting tumor recurrence. That seems like another huge leap.
The sources suggest potential there, yeah.
They reference Dr. Belinda Parker's research on personalizing cancer therapy based on immune pathways. The idea seems to be that RALF-1 could potentially help tailor therapies by predicting outcomes based on analyzing complex biological data sets.
So maybe the argument is that it's good at analyzing any complex system, not just geological ones.
That seems to be the underlying implication, yes. That the algorithm's strength lies in complex systems analysis generally.
And perhaps the most sensitive claim in these sources involves geopolitical or military applications.
Yes, according to the source material provided, it's claimed that RALF-1 can predict the intensity and areas of Russian bombings in Ukraine based on statistical data.
That's a very specific and serious claim.
It is. And as presented in the sources, they even include reference to a letter of thanks from the Ukrainian National Security and Defense Council for proposing the algorithm's use. Wow. Now, it's really important for us to state, and for you listening to understand, we are simply reporting the contents presented in the source documents here. These are the claims they make about the algorithm.
Absolutely. We're presenting the information from the sources neutrally, not endorsing these specific and, frankly, highly unusual claims about the algorithm's capabilities.
Okay. Moving from those wide-ranging, almost world-altering claims, let's maybe circle back to the more grounded applications, discuss the earthly commercial ventures tied to resource exploration.
Right. Because despite those broader claims, a significant chunk of the sources does detail specific projects and areas where this technology is being applied or considered for finding resources like oil, gas, and minerals right here on Earth.
Like in Poland, for instance.
Yes, there's research into the oil potential of Paleozoic rocks within the Antonine 1 gas field. They're using RALF-1 analysis of artificial electric fields. The sources even include some correlation graphs showing resistance versus polarizability at different depths.
And they mention companies involved there.
Companies like Dlaboki Geoservice LLC, PG Ein, and Antonin Eng Polska LLC are mentioned in relation to that Polish work.
Ukraine is another key focus in these documents, isn't it?
Definitely. The sources discuss the potential for oil and gas from granite formations, which, are typically not conventional reservoir rocks. Very unusual.
Right. Basement rock production is rare.
Exactly. And the Bialysky Block investment project by JSC SPC Ukrnaft Invest in the Odessa region is detailed quite a bit.
How big is that?
It's a large block, 994 square kilometers. And it apparently has existing, though historically challenging, oil reserves.
And the scale of potential resource mentioned in the sources for that Bialysky block is pretty substantial. They state a total aggregate potential extraction of at least 3.3 million tons for the first 10 years, just from existing fields within the block.
And they're seeking, $134 million in investment, highlighting its proximity to infrastructure.
The sources also note its history, with wells drilled way back in the late 60s and early 70s, and a pilot recovery attempt in 1988.
So the idea here seems to be that RALF-1 could be the key to finally unlocking potential in these historically difficult formations, making the uneconomic economic.
Similar potential for oil and gas from granite is discussed for the Siberian Plateau in Russia, too, right? Referencing publications by Vadim Chernov.
Yes, on prospects in the Russian Trans-Urals. The sources are definitely positioning this technology as key to accessing these unconventional reserves in basement rock.
And the geographic scope expands even further. There are mentions of potential hydrocarbon and kimberlite, that's diamond-bearing rock deposits in Saudi Arabia's Western Arabian Shield.
And near China, in areas like the Tarim Basin, Tian Shan, and the Tibet Plateau.
They even draw an analogy to the success of Vietnam's White Tiger oil field,
which famously produces from fractured granite basement. So they're trying to link it to a known, if unusual, SCUS story.
Are there other specific sites mentioned?
Yeah, a few others pop up in the context of correlations or projects. The Daydasht site in Iran, and the Mikhailovsky site in Russia's Kurgan Oblast, and EM research using RALF-1 in the southern Urals for depths up to 10 kilometers is also noted.
So we see this pattern, applying the technology to explore complex or unconventional geology across different continents.
And the sources also highlight these international partnerships, particularly involving Philippine companies potentially working on Siberian projects.
With Chinese firms like Jiangsu Linyang or CNPC possibly leading the funding or logistics side.
And Prime Energy in the Philippines is noted for having relevant experience from their Malampaya gas project, so drawing in established players.
There's also that curious detail connecting some of the individuals involved.
Ah, yes. Vadim Chernov's honorary membership in the World Relations Commission for Justice, Peace, and Development, or WROJPD.
Based in the Philippines.
Yeah.
And that group states focuses like human rights and environment and has this entity called Metamax Universal General Enterprises for revenue generation.
It just adds another layer, another interesting thread to the international connections discussed in the sources. Kind of unexpected.
Definitely. Okay, let's just briefly touch on some of the more technical geophysical nuances mentioned and then get to the critical question this whole stack leaves us with.
Sure. The Vanyan source, for example, provides useful background on the complex challenges involved in studying the deep Earth using electromagnetic methods generally.
Right. It talks about concepts like electromagnetic field penetration, the skin effect, which we mentioned, limits how deep EM signals can go.
And how that skin effect varies vertically and horizontally. Also things like anisotropy, where rock properties differ based on direction and different sensing modes like galvanic versus inductive.
It also mentions magnetotelluric sounding, which uses natural geomagnetic variations like storms and pulsations for deep study. It really provides context for just how complex deep EM exploration actually is.
And then the Juna Fatiga Z source adds some practical details about their HRES IP equipment generators, recorders, electrodes, that sort of thing. It seems related to this overall approach.
And it details data processing steps, quality control measures like acceptable error rates.
Yeah.
What were they?
5% amplitude, 2 degrees phase, something like that. And dealing with noise from power lines, wind, even people walking nearby. Standard operational challenges.
So these technical details help ground the discussion in real-world geophysical practice and the difficulties involved.
However, this brings us right back to the crucial point raised within the source material itself.
Yeah, what's that?
The sources explicitly state that the practical success of these resource projects and the sheer scale of the potential resource they discuss in places like Ukraine and Siberia, it's all presented as being entirely dependent on whether the RALF-1 technology actually works, as claimed.
So despite all the sophisticated discussion, all the claims about depth penetration, precision, and even predicting, weather or markets, the sources themselves acknowledge that the efficacy of the core technology, especially RALF-1 for interpreting that deep data, is the big unknown.
Exactly. The code analysis source you included specifically highlights this. It notes that the efficacy of RALF-1 remains unproven based on their analysis.
And it recommends caution.
Strongly. It recommends that anyone considering significant investments based on its outputs should absolutely consult independent local geophysicists to verify the results first, because it just isn't proven yet, according to that analysis.
So that's our deep dive into this really extraordinary stack of documents. We started by exploring a proposed geophysical method for sensing incredibly deep underground, maybe even useful for exploring other planets.
We then uncovered claims about an algorithm, RALF-1, connected to this method. And the sources position it as having predictive power extending into these incredibly diverse and unexpected fields: finance, weather, medicine, even military events.
Which is quite something. And finally, we circled back to specific, high-stakes, Earth-based projects focused on unlocking potential oil, gas, and mineral resources in really challenging geological settings.
Where the same, still unproven technology is being positioned as the absolute key.
This collection of documents paints a picture that is, simultaneously rooted in complex geophysical science and just strikingly ambitious in its claims for the RALF-1 algorithm's capabilities across so many different systems.
Thank you for sharing this truly fascinating and definitely thought-provoking material with us. It certainly gives you, the listener, a lot to consider.
And it leaves us with that provocative thought presented in one of the sources itself.
Right. And if really a technology born for searching for oil could offer a completely new window to see such different events, or maybe radically change the way we look at complex systems in so many disciplines.
What other fields could be transformed by such an approach to data analysis and forecasting? A big question to ponder as you process everything we've just explored.